Hello, this is Jaejun Lee, the presenter of the 18th KWIX Team Let's start the presentation. The table of contents of the presentation is as follows. The outline of our work is that the use of disposable cups in cafes increases exponentially every year, but on the other hand, proper separate collection of them are not performed properly, which has significant impact on environmental pollution. The actual proper separate collection means the process of sorting by material and cleaning it before collecting it. Accordingly, the Ministry of Environment announced a policy to impose a deposit for the use of disposable cups in cafes from June of this year. But from the standpoint of the cafe, which has to collect the disposable cups, many steps and owner of cafe expressed a negative attitude toward the policy. In terms of additional labor and manpower that would be incurred because there is no proper written system. Accordingly, the policy was delayed to December of the year, but it will be enforced to decrease the impact of the environment pollution. We conducted a survey on 123 general users of cafes. There were still many people who used cafe disposable cups, but they didn't properly understand the deposit policy. And most people were aware of the proper separate collection, so we thought that even though many people know the proper separate collection, they lack awareness about environment pollution, and there are restrictions on the circumstances in which to practice the proper separate collection. The following are the results of a survey of cafe employees who are engaged in cafe business. Surprisingly, everyone who surveyed expressed a negative opinion about the return of disposable cups in cafes caused by the cafe deposit system. Therefore, we thought that we needed a system that automatically separates and collects cafe disposable cups and can be installed anywhere, increasing accessibility and allowing anyone to use it conventionally without any assistance. And we thought that this automatic system could be made in the form of a vending machine to satisfy all the needs. This is the hardware architecture of our work. The main server and the STM board communicate with each other by serial communication, and STM boards operate the fan motor, DC motors, and pump motor in response to the command received from the main server and the sense value received from the sensor. These are images designed with Inventor tool and pictures of our work. In order to carry out the proper separate collection, first of all, the cup and cup lid are separated using a cup lid remover and gripper made with 3D printer. Second of all, the cup is washed through the pump motor and cup rail made by ourselves. And then, we made a mechanism for loading and storing cups by making a sorting rail and loading rail. Our machine takes 24 seconds to separate and collect one cup, and the total weight of the machine is 150 kilograms, and it can be rolled and stored about 600 cups. Available cup size range from 10 to 20 ounces for paper cups and 12 to 24 ounces for plastic cups. and available straw lengths are up to 210 millimeters. We use the position controller using PD control and speed controller using PI control to control the lathe motor that moves the gripper. Position controller and speed controller were also used to control the wrist rotation motor that rotates the gripper. Next is the software architecture. UI, socket communication, barcode recognition, cup classification, using deep running, and the serial communication with STM board are implemented with multi-threading in the server. Barcode recognition works as follows. These are the cup material classification results using deep running. This is UI implementation. And we implemented the application as follows so that the engineer can manage and supervise the state of the work remotely. This is the flowchart of our work. It starts with the user touching the return start button on the UI standby screen. If the motion recognizes the unique barcode of the recyclable curve and recognizes it as the correct barcode, it commands the user to return the curve. When the user returns the curve to the curve return port according to the command, the deep running model recognizes whether the curve is recyclable or not. When the correct paper curve or plastic curve without the cup holder is recognized, the return door is open and the cup falls into the machine. And the cup is mounted on the cup with separator, and the gripper servo motor operates to grip the cup, and the ray motor drives the cup to separate from the cup reed and moves the cup. When the gripper reaches the target point, the gripper wrist motor rotates 180 degrees and the pump motor sprays the washing liquid into the cup to clean the cup. The cleaned cup is placed by the gripper and cup is rolled along the lane. Afterwards, when it is confirmed that the cup has accumulated on the rolling rail to some extent by the PSD sensor, the DC motor installed on the rolling rail rotates to store the stacked cups horizontally. The following is a video of repeated operation for stability evaluation. It can be seen that the operation is stable even after 38 consecutive operations. This is general operation video. The first video is that the user uses our work directly, and the second video is internal operation of our work viewed from the left side, and the last one is internal operation of our work viewed from the right side. This concludes the presentation of the 18th Kwix Team P&L. Thank you.